All right, welcome to video 4 of Unit 8. We're finally going to figure out how to actually determine rate laws. So determining rate laws is honestly really useful, especially if you get data. If you ever get actually into ChemLab yourself, you can actually start making rate laws and again figuring out how to make reactions go faster. You've got the reactants, you can figure out which ones actually directly influence it the most. So they're really useful. Let's get started. So to determine a rate law, following steps will help. First off, construct the rate law with the concentrations of all species for which data is given. Now, I know step 1 basically sounds like saying do it all, but I mean write an idea of what your data is going to look like. For example, let's say you're given a data table and it's got reactants A and B or something. Your rate law then for step 1 would look like this. And then what we're going to do is basically plug in whatever numbers we actually know and kind of solve for whatever's missing. Or for example, if you were given data like with 3 variables, then your rate law could look like this, where it's still rate equals K, but then you just got the different reactants. I use P right here. It doesn't matter at all what letter you use. I just knew if I put a O, people would write it as a 0. So it's just all the concentrate, all the reactants to some power that we're going to be solving for. Secondly, we take ratios of the experimental data for which one reactant's concentration is the same in both. For example, if we were given data like this, if you're looking for A's reactant concentration is the same in experiments 1 and 2. B's is the same in 1 and 3. So what we're saying is basically make the rate law, let's pretend we're going off of A, make the rate law for experiment 1 and plug in these numbers, make the rate law for 2, plug in these numbers, and well, we'll get there. So that would look like this, where this top row is I plugged in these numbers to our rate law. So I said, all right, my concentration of A is 1, so let me plug in 1. I don't know what M yet, we're going to be solving for that, so I just left M. My concentration of B is 2, so I plugged in 2. And I said my overall rate is 5, so I plugged in 5 for my rate. Then I did that for another experiment. Again, I'm trying to pick one where A does not change. So now I plugged in 1, which notice these are the same value. Plugged in 4 for B and 10 for my rate. We'll eventually solve for K, but again, right now we don't know it, so we just plug it in. All right, so that's step 2. Step 3 is we're going to simplify that expression and basically solve for whatever exponent doesn't cancel. And then step 4 is we just kind of do that until we have all our rate orders. So let me bring back that reaction. We have 5 equals K times 1 to the M over 2 to the N, and 10 over 10 equals K times 1 to the M over 4 to the N. So hopefully you noticed, but this K is the same number, and this 1 to the M is the same number. That means we can basically cross those out. We're going to cancel those. So now what we're left with is 5 over 10 equaling to 2 to the N over 4 to the N. My hope is that you remember enough math to realize that this is actually equal to just 2 over 4 to the nth. Okay, basically what you do is we simplify this and we're going to solve for n. So this gets us 1/2 is equal to 1/2 to the nth. Now, whether you know this by common sense, whether you know this by some algebra powers, or whether you go back to that worksheet I gave you that helps you with logs, however you solve this equation, that's cool, because you'll get that n is equal to 1. That means that back in this equation, anytime now we repeat this process, instead of putting n, we'll just put 1. That enables us to cancel out more terms and eventually solve back for m. So again, cancel out what divides, solve for what you're left with. When you've got all your rate orders, you're done with your rate law. Well, now we're going to actually get practicing. So we're going to determine the rate law for this reaction. I'm going to walk you through this one. If you want to try it on your own, go ahead, but I'm just going to kind of talk through this. So first we got to actually determine what the general rate law for this looks like. We only have two reactants, A and B, and the C doesn't really factor in because it's a product. It's not a reactant. So that gets us kind of the standard rate equation. Rate equals K times A to the M some power and B to some power. Okay? Now, we pick two experiments in which either A doesn't change or B doesn't change. Well, the only real option we have is in experiments 1 and 2. B doesn't change. So, we write our ratio of those. That gets us this ratio. Okay, now we cancel out things. We can see that K disappears, and so does our B. This leaves us with that. I took out the M. Hopefully you remember how we do that. That'll simplify down to this. And finally, using logs or however you want to do this, we get that M is equal to 2. Okay? Now that we have M, we can actually go back, solve for N, and ultimately get our overall rate law. So, let's work on that. All we got to do is pick basically two different pairs of trials. It's not going to really help us to start with the same one. It's probably doable, but it's just weird. So last time, we used 1 and 2 because B didn't change. Our hope would be that we can find now 2 where A doesn't change. However, it's not really an option in this one. Often it is. Try to give you a harder one just to give you an idea of what you do when they don't. If you can find one where it doesn't change, it's simple. It's the same as last time. However, since we don't have that, we're just going to pick a trial, plug in our M, and solve as best we can. I'm going to pick number 2 and 3 because they look like the scariest ones. So, as of the last time, we start by actually making the ratio of rate laws, but we can actually plug in the value of M being 2 when we do that. That gets you this. Now, as of the last time, our K can cancel out, but we actually can't cancel out these because 2 squared is not the same as 1 squared. So we actually have to multiply those out. That gets us, though, actually what I'm going to do is I'm going to take this and divide it, this and show you divided, and kind of take this out and divide it. So that gets you basically simplified this, which is 38.4 over 4.8 is equal to 4 over 1 times 1 over 0.5 to the power of n. Okay, simplifying that more, we get that 8 is equal to 4 times 2 to the n. Kind of weird in my opinion that, it all comes down to basically even numbers. It's kind of the point of this, though. Anyways, dividing both sides by 4, we get that 2 is equal to 2 to the n. Now, most people probably know how to do this. You can probably tell me what exponent we raise 2 by to get to 2. And if not, we have issues. It's 1. But in case you did not actually know what it would be, what you're going to do is this. The log of basically the left number over log of the right number. Now in this case, that's going to be the same number, which is how we get 1. But let's say we have like 4 and 2 or something. If this was 4, then we'd put 4 on top. If this was 2, it just... That's how you can actually figure these out if they don't automatically click in your head. So, that, however, gets us that n is equal to 1. So we have m is equal to 2, n is equal to 1. So let me show you what our final actually answer will be. It is rate equals k times a squared b to the first. Often this is going to be enough. There are a few problems where you have to solve for k. Let me show you real quick how to do that. General, to be honest, I'm not going to ask you to do that much, so if you want to skip on, that's fine. Honors, yeah, you're going to have to know this. So, basically, all you do, this is true for every single trial. So all we do is pick a trial, plug in numbers, and solve for k. For example, I'm going to pick number 2. That would get us that 4.8 is equal to k times 1 squared times 0.5. Okay, simplifying, we get 4.8 is equal to 0.5k. Dividing both sides by 0.5, we get that k is equal to 9.6. Alright, now that's great, but to be honest, I've done this enough, and I've done it wrong enough, that I found basically a way to fix this. This is true for every trial. So to test this, plug this number in for one of the other trials, but leave rate empty and make sure that you can get that rate. For example, if I use number 3, I would get that, theoretically, 9.6 times 2 squared times 1 to the first. Well, when I multiply that out, I get 9.6 times 4 times 1, which 9.6 times 4 times 1 gets you 38.4. That means technically our more correct final answer is rate is equal to 9.6 times a squared times b to the first. As one final piece of information, you will occasionally be asked for the overall order of the reaction. The overall order is basically the sum of all the individual orders, which means that our overall order is simply 2 plus 1, which gets us 3. That should be enough to actually cut any homework, any rate law problem you need. Feel free to watch this. This is probably the longest slide in my history of video making. Hopefully it helps though. I'll show you the next example. I'm actually just going to put the rate law up. You can use this to practice, etc. Alright, here's our last example. I have worked completely through how to solve rate laws on the first slide. I want this video to be decently short, and I want you to have enough practice. What I'm going to do is I'm going to put your final rate law. I'll put it with k and without k. Well, without k, then with k. I'll even tell your overall order, just to give you that practice. So yeah. Alright, here's your rate laws. Hopefully that was enough time for you to pause and work, etc. So our rate is equal to k times a0 b1. Anything to the power of 0 is just 1, and we often don't write that in a rate law, which means our rate law is basically, k times b. Now, if I want to solve for k then, I would get that equals 1.64 times 10 to the negative 4th. Rather boring answer, sorry about that. Our overall order for this reaction is therefore just 1, because the only one that actually has a rate order non-zero is 1. Is b. You could do 0 plus 1, but that's the same number. Anyways, that's your rate law. That's your rate constant. Really boring. Overall order. Yay, rate laws. Thanks for watching.